Hello everybody. Today we will start with a new chapter, that is the atomic structure. Now, before we see into other details of this particular chapter, first let me introduce you some of the fundamental terms which would be required to use in this particular chapter. Okay, the first topic that we could say is about the fundamental particles. Now, we know basically the atoms, any atom that is made up of specially three fundamental particles. They are your electron, right? These are the three fundamental particles which make up any atom: electron, proton and neutron. Electron, that is symbolized as, in this way the electron is written. Proton, that is symbolized as, in this way. And neutron, that is symbolized as, in this way. Okay? Electron, that was discovered by Sir J.J. Thomson. Proton was discovered by Sir Goldstein. And neutron was discovered by Sir James Chadwick. Okay, if you compare them in terms of charge, so the charge carried by electron is minus 1.6 10 to the power minus 19 coulomb. Charge carried by proton is plus 1.6 10 to the power minus 19 coulomb. So you can basically see that electron and proton, they carry same magnitude of charge, but the sign of charge in both the cases is different, right? And neutron, जैसे कि आप नाम से समझ में आ रहा होगा, न्यूट्रॉन would carry zero charge, right? न्यूट्रॉन न्यूट्रल रहता है, it carries zero charge. Then, if you compare them in terms of mass, electron has a very small mass. It has mass of 9.1 10 to the power minus 31 kilogram. Okay? Whereas proton and neutron, इन दोनों का mass approximately same रहता है. That is 1.6 10 to the power minus 27 kg. ये आपका प्रोटॉन का भी मास है, ये आपका न्यूट्रॉन का भी मास. Approximately दोनों का मास same रहता है. Okay? And if you compare them in terms of where they are found, obviously the electrons are found around the nucleus. In the extranuclear region, the electrons are found. The protons and neutrons, both of them are found inside the nucleus, right? If we draw a basic structure of atom, we say atom is a sphere, right, which has a central core called nucleus. This nucleus, that comprises of neutrons and protons, right? And then at the outer end, we have electrons revolving around the nucleus. Right? This is the basic structure of an atom. Now, beyond these three fundamental particles, few more fundamental particles are there, which are we have, suppose, positron. Positron is another fundamental particle which is actually represented. Remember electron, I told you it is represented like this, right? The positron, that is represented in the opposite way. It is represented in this way. Means it has mass equal to that of electron but has positive charge. Okay? Mass is the same, but it will carry positive charge. Then Second fundamental particle excluding those three, that is your meson. Now meson, again there are two types, pi meson and mu meson. Pi meson has a mass nearly, you can say, 270 times that of mass of an electron. And this pi meson, it could be positively charged, it could be negatively charged, or it could be neutral also. Okay? Whereas this mu meson, this is another type of meson that is found, and it has mass equal to that of a proton. Okay? The third fundamental particle is your neutrino. Now this neutrino, as the name suggests, it will show similarity to your neutron. It has a mass equal to 1 upon 200 times that of mass of a neutron, and again it will be neutral in nature. Okay? So these are some of the fundamental particles which are found in different atoms. Now let us see some more terms. Now let us see about atomic number. Atomic number is represented by Z, and remember, atomic number is only and only equal to the number of protons found in the nucleus of an atom. Okay? Some students, they say atomic number is equal to number of protons or electrons in the atom. No. Atomic number is not equal to number of electrons. Atomic number only and only depends upon number of protons in the atom. Okay? For a neutral species के केस में हम जानते हैं कि क्योंकि वो न्यूट्रल है तो obviously total positive charge will be equal to total negative charge. So obviously उसमें total number of protons electrons के बराबर होगा. तो उस केस में हम बोल सकते हैं कि total number of electrons atomic number से भी हमें पता चलेगा. लेकिन अगर ions है, cation है, anion, positively charged ion और negatively charged ion, उस केस में atomic number will not be equal to number of electrons. That is why it is better to say that atomic number depends only on the number of protons. Okay? For example, if we take the case of sodium atom and sodium ion. Here, sodium atom, number of protons is 11. Okay? Sodium ion, again, we know whenever a cation or anion is formed, that is formed by the loss or gain of electron, right? There is no any change in the number of protons and neutrons in the species. So you can consider that the nucleus that acts like a jail for the protons and neutrons. Protons and neutrons cannot move out of the jail. Just like the prisoners, they cannot move out of the jail on their own wish, right? Whereas the electrons revolving around the nucleus, you can consider them as the common people. We, the common people, can move out of a city or move into the city as per our wish, as per the requirement, right? Similarly, any cation or anion which is formed, that is because of the loss or gain of electrons. The protons and neutrons remain same. Okay? So, in sodium ion also, number of protons would be 11 only. Now coming to number of electrons, here it would be 11 only because it is neutral in nature. So obviously total number of protons has to be equal to the total number of electrons, right? And in case of sodium ion, since it is carrying one positive charge, that means there must be a loss of electron so that the positive charge number of protons, it becomes more than the number of electrons. So number of electrons here would be 10. Okay, but atomic number in both the case is 11 only. So you can see atomic number depends only on number of protons, not on number of electrons. that is different in both the cases, but protons and the atomic number, they remain same. Then the next terminology that we would see is mass number. Mass number represented by A, okay, and it is defined as total number of nucleons in any atom. Nucleons is a term which is used for the collective representation of neutrons and protons. So you can also say that mass number is equal to the total number of neutrons and protons in any atom. Okay? For example, if you take the case of iron. Okay? Iron has an atomic number of 20. Now, whenever we write an element like this, always the subscript that represents the atomic number and the superscript that represents the mass number. Okay? So here atomic number is 26, right? That means number of protons is 26. Okay? Mass number is given as 56. That means sum of number of protons and neutrons is 56. So, if somebody asks you to calculate the number of neutrons, obviously I told you, if mass number is equal to number of protons plus number of neutrons, obviously number of neutrons will be equal to mass number minus atomic number. So number of neutrons in this case would be 56 minus 26, that is 30. Okay? The next term that we would see is about the isotopes. Now, isotopes means the atoms of same element, okay, different atoms of same element, remember, which have, obviously, if the element is same, they will have same atomic number. Number of protons will be same in those cases, but they will have different mass numbers. Now, same atomic number but different mass number. Why? Obviously, because of different number of neutrons. So they are called as isotopes. Atoms of same element having same atomic number but different mass number due to different number of neutrons. For example, the most common example of isotope that is considered is for the hydrogen. The hydrogen exists in three forms. This is called protium. Then we have deuterium and then tritium. Okay. Let us compare them in terms of mass number and atomic number. Atomic number, see, subscript in all the cases is 1 only. So obviously atomic number would be 1 only, and obviously they belong to the same element. So we know that any element is represented by its atomic number. Atomic number is used as a mark of identification for any element. So atomic number would be same in all the cases. If we see the mass number here is 1. Here we have mass number 2. Here we have mass number 3. So, number of neutrons in all. Number of neutrons in this case 1 minus 1, 0. Here 2 minus 1, 1. And here 3 minus 1, 2. Right? So you can see these three isotopes have have same atomic number but different neutrons number, therefore different mass number also. Okay. The next term that we would see is isobars. Isobars are atoms of different elements. Isotopes, they were atoms of the same element, different atoms of same element. But isobars are atoms of different elements, okay, which have same mass number but different atomic number. So you can say they are just the reverse of the isotopes, right? For example, if I take the case of argon, calcium and potassium, argon, potassium and calcium, all of them have same mass number, that is 40. Okay, but argon has atomic number 18, potassium has atomic number 19 and calcium has atomic number 20. So they are isobars of each other. Atoms of different elements having same mass number but different atomic number. Okay. Then the next term that we would see is isotopes. Isotones, they are the atoms of again different elements which have equal number of neutrons, but obviously if there are different elements, they will have different atomic number also and therefore different mass number also. If atomic number is different, obviously mass number will also become different, right? For example, if I take the case of silicon, phosphorus and sulfur, okay, silicon has a mass number 30, phosphorus mass number is 31 and sulfur mass number is 32. Atomic number of silicon 14, for phosphorus it is 15, for sulfur it is 16, right? But see, atomic number is different, mass number is different. Let us find the number of neutrons. Number of neutrons here, 30 minus 40, 16. In this case, 31 minus 15, again 16. 32 minus 16, again 16. So you can see atoms of different elements having different mass number, different atomic number, but same number of neutrons. Okay. The next term that we would see is isoelectronic species. Isoelectronic species means those atoms, molecules or ions which have same number of electrons. Remember, it is not necessary, it considers only atoms. Okay, it could be atoms, it could be molecules, it could be ions, anything. Okay, but they should have same number of electrons in them. Okay, for example, fluoride ion, atomic number is 9, but it has one extra electron in it. Normally the fluorine atom consists of 9 electrons, but since it has one negative charge, that means one extra electron is present. So total number of electrons in this, that would be 10, right? Let us take Mg2 plus magnesium atom has 12 electrons, but 2 electrons are lost. That means left electrons again 10. Neon atomic number is 10 only, so it has 10 electrons only because it is your neutral species. Then sodium ion, number of electrons in the sodium atom 11. Plus 1 charge means 1 electron is lost. That means total number of electrons here 10 again. Right? If we take ammonia molecule, nitrogen has 7 electrons and hydrogen has 1 electron. So 3 hydrogen having 1 electron each. 7 plus 3 again 10. Right? Then if we take aluminium ion, atomic number is number of electrons in aluminium atom 13. 3 plus charge means it has lost 3 electrons, and that means again number of electrons 10. Okay. If we take oxide ion, number of electrons in oxygen atom 8. 2 extra charge means 2 electrons have been gained. That means again number of electrons 10. If we take nitride ion, that means number of electrons in the nitrogen atom 7. It has gained 3 electrons. That means again 7 plus 3 10. So you can see all these species, some of them are charged, some of them are neutral, some of them are molecules, but they possess same number of electrons. That is your isoelectronic species. Okay? Now, then the next term is atomic mass unit. The atomic mass unit is defined as 1/12 of mass of an individual atom of carbon 12 isotope. Okay, and its value 1 AMU, that is equals to 1.6 10 to the power minus 27 kilogram. Okay, and we saw that the neutrons and protons, they are approximately equal mass that of 1 mu. In the initial only I told you their masses. It was approximately this only, right? But the electron, that is approximately 1836 times lighter than AMU. Okay, its value is equals to 1 upon 1836 times 1 AMU. Okay, and that is why whenever we find the atomic mass of an element, normally the mass of electrons is neglected. Atomic mass considers only the mass of total number of protons and neutrons in the particular atom. We do not count the mass of number of electrons in that atom. Okay. Moreover, we had also seen that electron and proton, they have equal but opposite electric charges, but the neutron is neutral in nature. It is uncharged. Right? Now, the existence of electrons, that was first suggested, as I told you, by Sir J.J. Thomson. Because of his, he actually conducted an experimental work on the conduction of electricity through gases at low pressure. It produced cathode rays and X-rays, and the study of radioactivity by the Becquerel, the Curies and Rutherford, they also confirm the existence of electron. Right? Now, remember, an atom is electrically neutral if it contains negatively charged electrons equal to the number of positively charged particles. Right? And since when the electrons were discovered, at that time protons were not discovered. Right? So since atom is electrically neutral, therefore there must be some positively charged species, which is making the atom overall neutral. So that led to the discovery of protons by Sir Goldstein. Okay. Alright. Now let us see let us discuss in detail the discovery of electron. Now electron that was discovered by Sir J.J. Thomson, right? Now what happened during the later half of the 19th century? It was found that normally the dry gases they do not conduct electric current. Okay, under ordinary conditions the dry gases would not conduct electric current. But if the pressure was reduced very low, if the pressure was decreased very much, then the gases they started conducting electricity. Okay, it was found that certain light patches of light they were found in the particular gas. Okay, and the passage of electricity through the gases they were studied by a number of scientists, and the most significant study that was done by Sir J.J. Thomson, which led to the discovery of electron. When a current of high voltage, say 10,000 volts, this much high voltage, when it was passed through a gas of air, kept at a very low pressure. The pressure was approximately 0.01 to 0.03 millimeter, or you can say 10 to the power minus 4 atmosphere. This much low pressure was there. Then in that case it was found that some sort of invisible rays they were seen moving from negative electrode to the positive electrode. Okay, if we see the tube, the apparatus which Sir J.J. Thomson used for the discovery of electron, there was okay, so you can see Sir J.J. Thomson he used this is known as a discharge tube. Okay, and the common tube, discharge tube, that you can see consists of a hard glass cylindrical tube. Okay, there are two metal electrodes on either ends, and it is connected to a side tube here. It is connected to a side tube here through which it can be evacuated. The pressure inside the tube could be reduced with the help of a vacuum pump. Okay, and then the end which was connected to the positive end, that was called as your anode, and which was connected to the negative end, that was called as cathode. So when the electricity was passed through this at this high much voltage of electricity, it was passed through this low pressure of gas inside the tube. Then what happened? From cathode to anode, some rays were emitted, because of which at the back end of the anode a green glow was observed here. A green glow was observed. Okay. Now, since these rays they traveled from the negative end to the positive end, so that means since they are moving towards the anode, that means obviously they should carry some amount of negative charge on them. That is why they are being attracted by the anode, right? And since they were emitted from the cathode, therefore they were called as cathode rays. cathode rays. Now let us see some of the important features of the cathode rays. The first important feature of the cathode ray was that they would always travel in straight lines. The cathode rays would always travel in straight lines away from cathode at very high velocity. Their velocities that was approximately 10 to the power 9 to 10 to the power 11 centimeter per second. With such a high velocity, they will move in straight line from cathode towards the anode. And if any metallic object was placed in the path, they would cast a shadow of that metallic object on the wall opposite to the cathode. Okay? The shadow would be casted on the wall opposite to the cathode. Okay? Second feature was that these cathode rays, they would always come out at right angles to the cathode. Always, whatever be the position of cathode, they would be always emitted at right angles to the cathode. Moreover, their path, that is independent on the position of anode. Their path will depend only on the cathode but is independent of the anode. Then, next property was that they would produce phosphorescence. They would produce phosphorescence on certain salts like zinc sulfide, and on striking a glass, they would produce fluorescence on glass. Okay? They also affect photographic plates. Okay? Moreover, they can penetrate through thin metal sheets. Remember, only through thin metal sheets they can penetrate. Okay? But if the metal sheet is too thick, then they cannot penetrate, they will rather cast a shadow. Okay? Moreover, they would produce a green glow when they would strike the back end of the anode. Okay? They produce X-rays. X-rays are highly penetrating rays. These X-rays are produced when they strike a metal having high atomic mass. Okay? They also cause ionization in the gas through which they pass. Okay? Then they show heating effect. The heated substance when they collide with the matter. That means they must possess some kinetic energy which is being converted into heat energy when they are stored by the matter. Right? Then they rotate a light paddle wheel which is placed in their path, which also shows that the cathode rays, they contain material particles having both mass and velocity, which on striking a light paddle wheel, the paddle wheel would start rotating. Right? Then, if we see their mass, the mass of the particle present in the cathode rays is found to be approximately 1 upon 1837 times particle is of subatomic nature. Another property is that they are deflected by a magnetic or an electric field, which shows that the particles are electrically charged and they are deflected towards the positively charged electrode in an electric field, which shows this direction of deflection that shows that these cathode rays are negatively charged. Similarly, in a magnetic field also, the cathode ray, they are deflected from the normal straight path to a curved path. Okay? Next property is that these cathode rays, they contain the smallest unit of negative charge. Okay? And remember, no cathode ray was produced when the tube was completely evacuated. Okay? Again, different gases would produce same cathode rays. Why? Because different gases have same E by M ratio. E by M is charge by mass ratio, which shows that the particles present in the cathode rays are fundamental constituents of all matter. Moreover, the nature of the cathode rays that was independent of first nature of cathode and second the type of gas in the discharge tube. Okay, so these were the some main properties of your cathode rays. Now Sir J.J. Thomson named these negatively charged subatomic particles as electron, which made up the cathode rays. And so electron, we can define it as a subatomic particle which is a fundamental constituent of all matter. Fundamental constituent in the sense they are present in all the matters. In every atom that consists of your electron, right? Having a mass equal to 1/1837 that of the mass of an hydrogen atom, and which carries a unit of negative unit of fundamental charge. Okay, that is called as an electron. Okay, now let us see how the velocity and charge by mass of the electrons were determined. Now, Sir J.J. Thomson, he actually extended the cathode ray experiment for the determination of velocity of electrons and to find their E by M or the charge by mass ratio. And how did he do so? By studying the deflection of the cathode rays in the electric and the magnetic field. And he found that E by M ratio for the electron, it came approximately minus 1.76 10 to the power 8 coulomb per gram. Okay. For the proton, we will see later. For the proton, the E by M ratio that was simply equals to 96,500 divided by 1.008 coulomb per gram. For the proton, for the electron, this was minus 1.6 10 to the power 8 coulomb per gram. Okay. Now let us see how he calculated the values. I told you he studied the deflection of electron in the electric and magnetic field, right? Now, in case of electric field, it was found under the influence of electric field, whose path was given by y, that is equals to upon small e, capital E upon 2 m v square multiplied by x square, where y is the deflection in the path of electron in the y direction. Okay, small e is the charge on electron, small m, that is the mass of electron, small v, that is the velocity of electron, E, that is the strength of the applied electric field, or you can say intensity of applied electric field, and x, that was the distance between the electric plates within which the electron was moving. Okay. Right. Then he also studied the deflection in case of magnetic field. The path of electron in the magnetic field was found to be circular. Okay, with radius r. The radius r, that was given by mv upon ev, where again r is the radius of the circular path, m is mass of electron, v velocity of electron, e charge of electron, the same terms that we saw earlier, and b is intensity of applied magnetic field. So you can see here, now mv is what? mv, mass into velocity, that is equal to the momentum, right? So radius, that is proportional to the momentum of the electron. We can say that radius of electron in the magnetic field is, radius of the path of electron in the magnetic field is proportional to the momentum of electron, right? Now two equations we have seen. Using those two equations, Sir J.J. Thomson gave the following relation to calculate the charge by mass ratio. He said E by m, that could be calculated by the ratio capital E, intensity of the applied electric field, divided by r, radius of the electron in case of your magnetic, radius of path of electron in magnetic field, divided by b square, where b was the intensity of the applied magnetic field. Okay, and by this we found the value minus 1.76 10 to the power 8 coulomb per gram by putting in the respective values. Alright, now let us see one more term. That is the rest mass of electron. Now rest mass does not mean mass of electron at rest. Obviously, the electron cannot rest. If its velocity becomes 0, it will be attracted strongly by the nucleus. It will fall in the nucleus. The atom would collapse. Right? Rest mass of electron is actually the mass of electron when it is moving with the low speed. And normally, the mass of moving electron, that is given by the relation rest mass of electron divided by under root 1 minus v upon c whole square. Okay, and it has been found that rest mass of electron is 9.1 10 to the power minus 31 kilogram. Okay, here v is what? Velocity of electron, c is the velocity of light. So now, if suppose equals to c. If let us assume that the electron it acquires the velocity equal to the speed of light. Then if you put in the value here, then mass will be what? Mass will be the rest mass divided by under root 1 minus d upon v, we can say, right? So this will be equals to rest mass divided by 1 minus 1 square, right? So that means it will become infinite. If velocity of the electron becomes equal to speed of light, mass of the moving electron will become infinite, right? And if suppose the velocity of electron becomes greater than c, okay, let us now assume that we take v is equals to 2c. Suppose velocity of light is greater than c, okay, then in that case mass will be what? Rest mass divided by under root 1 minus 2c upon c whole square. That would come as r rest mass upon 1 minus 4. That means rest mass upon under root minus 3. So this term will become imaginary, right? So if the velocity of electron becomes greater than the velocity of light, the mass of the moving electron will become imaginary. Okay? Now, let us see the mass of electron relative to the hydrogen atom. Let us see how the relation that comes. Okay? Normally, mass of hydrogen atom is how much? 1.008 AMU. This is the mass of hydrogen atom. We know 1 AMU is equals to 1.6 10 to the power minus 24 gram. So let us convert this mass into grams. So it would be 1.008 1.6 10 to the power minus 24 gram. That comes as approximately 1.67 10 to the power minus 24 gram. Okay, let us find the relation between mass of hydrogen atom and mass of electron. Okay, mass of hydrogen atom we saw 1.67 10 to the power minus 24 divided by mass of electron we know 9.1 10 to the power minus 28 in grams. So it comes as 1837. That is why I told you that mass of electron that is equals to 1 upon 1837 times mass of the hydrogen atom. Or in other words, you can say that is equals to 0.000549 times the mass of your hydrogen atom. Okay? This much AMU you can say. Okay? Now, Sir J.J. Thomson, he calculated the charge by mass ratio for the electron. But the charge of the electron that was found by Sir Millikan. So let us now see how the charge on electron was calculated. There was a scientist Sir R. Millikan. He conducted oil drop experiment to find out the charge on any electron. Okay, he actually measured the charge on electron by his oil drop method. In his experiment, what he did was he sprayed you can say some oil droplets by an atomizer. Let me roughly draw figure here. Now, suppose this is the apparatus, okay? At this end, we place an atomizer, okay? This is an through this opening into this viewing chamber. There was a microscope which was fitted here. A viewing apparatus that was fitted here. Okay. Now often these droplets, this particular this plate that was charged, it was connected to wires. So one carried positive charge, another carried negative charge. Okay. Now when these particles they were sprayed inside this viewing chamber, you could observe them with the help of microscope. Now often these droplets they consisted charge, okay, and how this charge came into existence on these oil droplets? Because of the friction between the oil droplets, okay. These droplets they would carry electric charge which developed because of the friction forming the oil droplets. Now a droplet it can have one or more additional electrons in it, because of which I am drawing a single droplet here. Droplets would develop negative charge on them. Now, as the droplets fall towards the bottom of the chamber, it will pass through two electrically charged plates. Right? Now, we would adjust the voltage in the plates such that, obviously see, the droplet that will be under the influence of gravity, force of gravity, this droplet here, it would be attracted downwards by the force of gravity, and since it is carrying negative charge, it would be also attracted upwards because of towards this positive charge, right? The positive charge, this electric plate that will attract the drop upwards, right? Now, this droplet, it was suspended between them. So, how we would adjust the voltage in the plates such that the electrical attraction upward just balances the force of gravity downward. Okay, and then we use the voltage needed to establish the balance to calculate the mass to charge ratio for this droplet. Now since we already know the mass of the electron, so we can easily calculate the charge of the electron. Right? Here this was the positive plate. Here we had another electric plate which carried negative charge, and in this way the balance was maintained. So this particular drop, it would neither fall on the ground nor it will move towards the positive plate. It will remain suspended in between the air, in between the two plates. It will remain here only. Okay. Now, Millikan found that the charge on all oil droplets could be expressed in the form of whole number multiples of E, where the value of E is 1.6 10 to the power minus 19 coulomb. Okay. And by combining the charge by mass ratio, he found that mass will be what? Mass of electron, we can write it charge divided by E by M ratio. We can write it in this way. E value we have 1.6 10 to the power minus 19 coulomb. Right? E by M ratio we have 1.76 10 to the power 8 coulomb per gram. Solving it, it comes as 9.1 10 to the power minus 31 kg, or 9.1 10 to the power minus 28 gram. Okay. This very small value of mass of electron shows that electron is a subatomic particle. Okay. Now, the radius of the oil droplet in the Millikan's oil droplet experiment was given by the formula R. R is the radius of oil droplet, which was used to find out the charge of the electron. That is equals to under root 9 neta V1 divided by 2 F minus sigma G, where Eta is what? This is the coefficient of viscosity of the gas medium. Okay? V1, that is the terminal velocity. Okay? F, that is the density of oil. Then sigma, that is the density of gas. G is the gravitational force. Okay, and the charge on the electron, it was given by the ratio. Okay, I'll rub it. The charge on the electron, it was given by pi neta r V1 plus V2, where again eta is your coefficient of viscosity of the gas, r radius of the oil drop that we just found out. V1 and V2 are the terminal velocities divided by E. E is the electric field strength. Okay. Now I am using a term here, terminal velocity. Terminal velocity of any falling object is actually the velocity of the object when the sum of the drag force, okay, sum of the drag force and buoyancy, that equals the downward force of gravity, okay, acting on the object. Now since the net force on the object is 0, obviously the object will have 0 acceleration, right? The force acting upward is equal to the force acting downward. Obviously the object would become stationary. The object will have 0 acceleration, right? Normally in fluid dynamics, this drag force, it is sometimes also called as air resistance, or you can say fluid resistance. Okay? Now let us see the discovery of proton, or the discovery of proton. Let us discuss it in our next class. Okay? Thank you.